Hello, this video will cover section 1.7, simplifying rational expression of the class Math 0305 with the co-requisite of Math 1324. The purpose of this lesson is to get you familiar on how to simplify rational functions and also to understand what a rational function is at a basic level. And so while we simplify the rational functions, we're going to be using some of the factoring techniques that we cover in section 1.4. So first, let's go over the definition of a rational expression. And a rational expression is a fraction that has a polynomial function in both the numerator and the denominator. Its domain, which is the set of all the x values, is all real numbers except for those that make the denominator equal 0. So we're going to be, not in this lesson, but in your 1324 class, you will be required to find those values that will make the denominator equal to 0 so that you can exclude them from the domain of a rational function. Steps to simplify a rational expression, and we call them expressions because we don't have them equaling to a dependent variable such as y, for example. So the steps to simplify the rational expression, first we're going to see if we can factor the numerator and the denominator. Sometimes we're going to be factoring into the product of two binomials. Sometimes we might have to start by factoring a greatest common factor, a GCF. Then after that, we note the values of x that are not in the domain. And 3, we remove the common factors that are both in the numerator and the denominator. So we're going to get started with example 1a. And for this one, I use the technique to factor, in which we convert the trinomial into a polynomial of 4 terms, and then we factor by grouping. So what I did here is I multiplied a times -3, I get -24. And then I broke down 24 into all the possible factors that I could have. So I could have a 1 and a 24. And we could tell that since the sign is negative, we're looking for a positive and a negative factor. So 1 and 24, we will have to make, since this one is a positive 10, we will have to make the column over large factors, the positive, and the small ones will be the negative. So 1 and 24, or -2 and 12. Also -3 and +8. And also -4 and +6. However, the only combination that gives me that +10 that we need here, it will be the -2 and the -12. And so I need that because I am going to rewrite this expression. And I'm going to separate the 10x by using those factors, -2 and +12. So it will be -2x and +12x. And you know, if you go back and combine those two, you will get the +10x that I have circled in red. And then let's not forget, we still need a -3 here. Now for the denominator, we're going to do the same. We're going to multiply 2 times -15. That will give us -30. And then we're going to look for the factors that will give us, when we multiply them, we get -30. And when we add them, we get -7. So we could have 1 and 30. Now, since we're looking for something that when combined is negative at the end, we're going to assign negative sign to the column of our large factors, which is the second column. So positive 1 and negative 30, that will give us, if we add them, it will give us negative 29, so that's not what we need. Let's see, positive 2 and negative 15. When we add those, we will get negative 13, so that doesn't work. And then you use positive 3 and negative 10. Now, once you combine those two, you will get negative 7, and that is what we're looking for. Two factors, and when we combine them, we get negative 7. So we're going to split that term, negative 7x, with those factors that we found. And now what I want to do is keep the negative 10. I'm going to write the negative 10x first, and then the positive 3x, and then lastly the 15. The reason I did that is because 2x squared and 3x have no factors in common, and so that wouldn't work for the grouping that I'm about to do. So from here, what I can do is make two groups. One group will be here. We have a positive sign, so that's good. We don't need to worry about changing our signs inside the parentheses. Then I'm going to group this two, positive sign again, so I can just enclose those. Now, from each group, I'm going to factor a greatest common factor. And so for the first group, between 8x squared and negative 2x, it will be 2x. Factor that out. 8x squared divided by 2x will give me 4x. Then negative 2x divided by 2x will give me negative 1. Now I'm going to factor the GCF from the second group, and that it's going to be a positive 3. So if I factor out positive 3 from 12x, I will get 4x. Negative 3 divided by 3, I will get negative 1. So now we're going to do the same thing for the denominator. First group, we're going to factor out 2x. And then from the next, well, same group, sorry. 2x squared divided by 2x will give me just 1x. And then negative 10x divided by 2x will give me negative 5. For the next group, we will be factoring a positive 3. And 3x by 3 will be x. And negative 15 divided by 3 will be negative 5. Now, what I want to do is write down my factors. So the first factor for the numerator will be 2x plus 3. And the second factor will be that one that they have in common, 4x minus 1. And the order doesn't really matter here. We could write 4x minus 1 first. Here, I'm going to write the factor that they have in common first, the x minus 5. And my next factor will be coming from here, 2x plus 3. Now, because 2x plus 3 divided by 2x plus 3 is equal to 1, we may say they cancel, but they don't disappear. They just equal 1. So we don't need to write them again. However, for the purpose of the domain, they will still be relevant. Now, after canceling those two factors, oh, well, we don't need this anymore. We will just have 4x minus 1 on top, and then on the bottom, we will have x minus 5. And that's it. That is the final answer after canceling.
Now, if you were asked to find the domain, you will have to exclude positive 5 because that will cause that denominator to equal. But we should also consider this factor when finding the exclusion for the domain. Now I'm going to move on to the next problem. And here, one thing that I can do right away is going to be, I can actually not cancel, but factor a greatest common factor from here. And so that is going to be from x cubed, negative 4x squared, and positive x. The greatest common factor is 1x. Then we factor 1x from each term, so 3x cubed divided by x is 3x squared. Negative 4x squared divided by x will be negative 4x, and positive x divided by x will be positive 1. On the bottom, we don't have a greatest common factor, so we're just going to factor that into the product of two binomials. Will be x and x. The sign is negative, so our signs inside the binomials will be one of each, a positive and a negative. And the factors of 3 are just 3 and 1. And here we just need to be careful which one is positive and which one is negative. So 3 has a bigger absolute value. And so because this term is positive 2x, that means that the number with the factor with the biggest absolute value will have that positive sign. So 3 goes here, positive 3, and negative 1 goes here. We still need to finish factoring the numerator, so that will be the product of two binomials. So we'll have 3x and x. Now, this sign being positive, it tells me that we have two options. Either both sides are negative, the ones that go inside the binomial, because the product of two negative numbers is positive, like positive 1, or they could be two positive numbers multiplying each other. Now, we already know that the only factors of 1 are 1 and 1. However, the sign being negative, the one in front of the 4x, that tells me that we're going to go with this combination, two negatives. So negative and negative. On the bottom, we have x plus 3 and also x minus 1. So we can see that factors in common will be x minus 1. That's it. That's all we can cancel. And the reason we cannot cancel this x with this x here is because this x is a factor, so that's okay. We could, but the fact that this one has a plus 3 next to it, that makes it be a term. And here you have a factor. Complete factor will be everything in parentheses. It's a factor with two terms. And you cannot just cancel the x. You will have to cancel the x plus 3. So to write down our final answer, it will be x times 3x minus 1 divided by x plus 3. Now, if you want to simplify this a little bit more, we could multiply x times 3x squared times 3x, so it will give us 3x squared, and then x times negative 1, so that will be negative x. And on the bottom, we'll have x plus 3. Now, the next problem 1c, it does have a greatest common factor, so I'm going to factor that out first. From 2x squared, if we factor out 1x, it will be 2x. And then positive x, factor out 1x, you get plus 1. On the bottom, we could also factor out an x. 2x cubed divided by x will be 2x squared. 7x squared by x will be positive 7x. And then 3x divided by x, it will be positive 3. Now, one thing I can do is I can go ahead and cancel these two numbers, or terms, or factors, I should say, x and x, because together that equals to 1, and so I don't need to write them anymore. However, the trinomial that we have here, it could still be factored, so I'm going to do that. 2x plus 1 is still the numerator. And then on the bottom, we will have the product of two binomials, so 2x and x. The sign is positive, so that tells me both of my signs will be positive. Well, both of my signs will be the same, but because this one is also positive, that tells me both are positive. So the only factors of 3 are 3 and 1, but we just need to make sure we place them correctly. So if I put my 3 here and my 1 here, and then I want to check, I will get 2x multiplied by 1, and that will give me positive 2x. And then I will multiply 3 times x, and that will give me 3x. Now, if I combine them or add them, I will get 5x. And so I don't want that. The number that I'm looking for as the middle term is positive 7x. So it's not a big problem. We just need to switch the position with the numbers 3 and 1. And since they're both positive, we're not concerned about that sign. So 3 will go here and 1 will go here. Now let's check those two factors. And 2x times 3 will give me 6x. 1 times x will give me x. If I add them, they're both positive, so that will give me 7x, which is the term that we were looking for. So now that tells me we do have the correct factors, and now we can move on to eliminating the two that are the same, 2x plus 1, since we have it on the top and bottom. Remember, they don't disappear, they're just equal to 1. And in fact, we still have to write number 1 on top because we have to write something, and that something is not 0. It will be the one that comes from this division. And the denominator, we still write x plus 3. And that is the simplified version of it. Now, for the next problem, we do have something that we call a difference of squares. It looks so, I guess, not the way we're used to see it. So I'm going to factor out a -1 from it. And I do that because I want to change the signs of the constant in the x square. So it will go like this. Now, on the numerator, we're going to factor it as two binomials, the product of two binomials. So that one is easy. We have x squared, so x and x will be our first terms for the factors. And then since this is a -15, that tells me that our signs in the middle will be one of each, a positive and a negative. Now, the factors of 15, we can say is 1 and 15, or 3 and 5. However, we have a positive and a negative, and because this 2x is positive, that means that the column with largest absolute value keeps the positive sign, and the column with the smallest absolute value keeps the negative sign. And the combination that will give us a positive 2 when we add them or combine them, -3 plus 5, that equals to 2 positive. That will be -3 and positive 5. So that tells me that -3 goes here and positive will go here. Now, what I'm going to do is rewrite the binomial that is in the denominator, but I cannot forget about the -1 that I had to factor at the beginning. And so I want to just switch the order so that x squared goes first and then -9. And the reason I do that is so that now it becomes more obvious that it is a difference of squares. And so when we factor it, we will be able to find a factor that is the same as one of the factors from the numerator. So here, -1, we still need to account for it. And to factor a difference of squares, we need to take the square root of this term, so that will be x, and the square root of 9, that will be 3, and could be positive 3 or negative 3. And that's how we factor a difference of squares. Now from here, we could see that x minus 3, we have it in common, and so we are going to go ahead and cancel it. And so now we have x plus 5 on the numerator by itself. On the bottom, we have negative 1 times x plus 3. So one thing we can do here is distribute that negative 1. So we'll have x plus 5 divided by negative x minus 3. And so that could be your final answer. You could also decide to distribute the negative 1 on the top, and so that will be negative x minus 5. But if you distribute the negative to the numerator, your denominator should remain like it was here, x plus 3. And that is the end for that problem. We have 2 more problems on the next page. And for this first one, we're actually going to factor out a GCF first, the greatest common factor. That's going to be the number 4. So 8x squared, if we factor out a 4, we will get 2x squared. Negative 44x, if we factor out a 4, we get negative 11x. And positive 60, factor out of 4, we will get a positive 15. On the bottom, we also have a GCF, a greatest common factor, that we could factor out. So that will be a 6. And 6x squared divided by 6 will give us x squared. Positive 18x divided by 6 will give us a positive 3x. And negative 8 divided by 6, it will give us negative 18. Now from here, we do have trinomials. So we're going to try to factor them into a product of 2 binomials. Now I'm going to start the one on the denominator because it is easier since the leading coefficient here is a 1. And so I will factor x squared with, the only way to factor it is by multiplying x times x. Then again, the sign is negative, so that means my signs that follow the x will be 1 positive and 1 negative. Factor of 18 that we could use will be of negative 18 actually. It could be 1 and 18, 2 and 9, 3 and 6, and that's it. But let's see how we need to assign the positive and negative sign to the factors. So because we have a positive 3 here, positive 3x, that means that the column with the largest factor is the one that keeps the positive sign. And this one will be negative, the column with the smallest factor. So we need to get a positive 3x, and so by combining or adding the numbers, we will get it from this combination. Negative 3 plus 6, that is equal to 3. So that means that 6 will be positive and 3 will be negative. Now, the factors of the other polynomial, the one on the numerator, are not so easy to find because we have a 2x squared here. Although that is not too hard to factor, we do have a 15 here. And so with 15, a positive 15, we could have factors 1 and 15 or 3 and 5. And because we have a negative here, that means the column with our largest absolute value keeps the negative sign. And what I'm going to try to do is something similar to what I did on the last page. I'm going to try to break this term negative 11x into two terms. So what I need to do, oh, and I just realized I was not supposed to find the factors of 15, but the factors of 30. So I'm going to have to correct this. I apologize. And the reason we need factors of 30 is because we need to multiply 2 times 15. And 2 times 15, positive 15, I should say. So not negative 30, but positive 30. So now we're going to try to find the factors of 30. So they are both going to be of the same sign. But because the term that we have there in the middle is a negative 11x, that tells me that both of my factors will have a negative sign. So we could have this. Negative 1 times negative 30, or negative 2 times negative 15, or negative 3 times negative 10, or negative 5 times negative 6. All those numbers will give us positive 30 when we multiply them. But the one that we need is the one that when we add them will give us negative 11, and that will be negative 5 and negative 6. So what I'm going to do is take that polynomial, and I'm just going to write down here. So it is 2x squared minus 11x plus 15. And like I said, we're going to separate this 11x by using the coefficients negative 5 and negative 6. So 2x squared. Now here, I'm going to place negative 6x first because negative 6 and positive 2 have a factor in common. That will be a 2. And negative 5x will follow because negative 5 and positive 15 have a factor in common. And now I'm going to group my first two terms, 2x squared and negative 6x together. Now I need a positive sign here, parentheses, and then negative 5x plus 15. Now I'm going to take the common factor from my first group, which is 2. And if I factor out a 2 from 2x squared, I will get, actually I should factor out a 2x, sorry. So 2x squared, factor out 2x, I will get x. Negative 6x, factor 2x, you get negative 3. From the second group, we will be factoring a negative 5. And the reason we factor a negative 5 is because we want this first factor that will come from here to be positive x. So if we have negative 5x and we divide by negative 5, then that will take care of our negative divided by a negative, and the answer will be positive x. And that's what we want. We want a positive x so that it is identical to this other factor here. And then we have positive 15 divided by negative 5, that will be negative 3. So you see it works. Now we do have that factor in common. And so that will be the first factor, x minus 3. And the next factor will come from here and here, 2x minus 5. Now I'm going to go back to the top and write them down. So we have x minus 3 and 2x minus 5. So 2x minus 5 goes here. And the other one was x minus 3. So now we see that x minus 3 is repeating. So now here we could eliminate those. And what we will get is, well, let's go ahead and simplify these numbers. They're both divisible by 2. 4 divided by 2 is a 2, and a 6 divided by 2 is a 3. So we have that, and then times 2x minus 5. And the bottom will be 3 times x plus 6. Now from here, we could leave it like that, or we could simplify it a little further, and we could say that it will be, well, we had 2 times 2x minus 5. And on the bottom, we had 3 times x plus 6. And so here we could go ahead and distribute the number 2. 2 times 2x will be 4x. 2 times negative 5 is negative 10. And on the bottom, we have 3 times x, 3x. 3 times 6, 18. And so that could be also your answer. Now, the last problem, on the top, we do have a difference of squares. So we could factor it as the product of two binomials. The square root of x squared is x. The square root of 4 is 2. And we make one positive, one negative. Now, the expression on the bottom is what we call a difference of cubes. To realize that it is a difference of cubes, you could rewrite it this way. 8 is equal to 2 to the third power, so we could do that. Now, after that, we could factor it as the product of the cube root of x cubed, which will be x, the cube root of 2 cubed, which will be, or negative 2 cubed, I should say, which will be negative 2. And then here we will have a trinomial, and this trinomial will come, the square of that term will go here. Then the square of negative 2 will go here, which will give us positive 4. And then for some reason, the rule states that if you start with a difference of cubes, then your sign that will follow x squared will be the opposite, so it will be a positive. And the term that goes in the middle will be just the product of x times 2. So that will be 2x. In this case, we do not need to double it. And from here, I'm going to delete some stuff. Unfortunately, I cannot just press the eraser because it will erase everything. So let's see, we have factors in common, x minus 2, x minus 2. And so now all we have left will be x plus 2 on the numerator. Denominator will be x squared plus 2x plus 4. And that will be our final answer. That concludes the video, so thank you for watching and paying attention, I hope.